Okay, so now we're going to talk about proof by cases. So this is where we break the statement we want to prove up into a finite list of collections of cases. And show that it works. And prove our statement for each of these. Elements of our list. So most of the work for these guys is going to be figuring out a collection of, or our list of cases that are going to make it easy to prove. Because usually there's infinitely many ways that we can break up our collection, our cases, but we want to break it up in a way that's going to be easy to prove. So I'm going to start off, and you guys are going to see this example again later because it's a classic example of proof by induction, but there's another kind of completely substantively different way we can show this, and that's proof by cases. So we wish to show that the sum of I from I equals 1 to n is equal to n times n plus 1 over 2. So we will break this up into cases where n is even and n is odd. So first assume that n is even. And let's, just because this is probably the first time you guys have ever seen this statement, actually just show that it works for the first few cases. So if n is even, then we're worried about 1 plus 2 is going to be equal to 2 times 2 plus 1 is 3 over 2 is equal to 3, and that checks out. We can also do 1 plus 2 plus 3 plus 4. So that, according to this formula right here, is going to be equal to 4 times 5 over 2 is equal to 10. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So if we have, if n is even, then we can write our list out as 1 plus 2 plus 3 plus n minus 1 plus n, blah, blah. And we can do this in such a way that if we pair up, we can pair up our first element and our last element, our second element and our second to last element, and so on. And this will break it up into n over 2 sums that all add up to the same thing. So therefore, we can pair up our first two, our first and last, second and second last. More space here. To get n over 2 pairs that add to n plus 1, because this guy plus this guy is going to be equal to n plus 1. This guy plus this guy is going to be equal to n plus 1. And each time we add 1 here, we subtract 1 here, meaning that we'll always add up to n plus 1. Therefore, the sum is equal to n over 2 times n plus 1, which is just n times n plus 1 over 2. Therefore, it works for the case where n is even. What if n is odd? So if n is odd, then we should have